Hey guys, and welcome back to another A-level maths video. This time we're going to go through solving trigonometric equations, and this is one of the kind of first topics that we've gone through that is really quite tricky, depending on how you want to solve these equations that we're going to be doing. There are three main ways. I'm going to show you, in my opinion, the best way to do it, which is something called the cast diagram, but I know that some people prefer to use either the rules in terms of just adding and subtracting certain numbers, and some people like to use the graphs, but I personally think that the cast diagram is definitely the best. It's something that even A-level students struggle with, so it's quite involved. This is going to be a very long video, and this is one of those kind of topics that I would definitely recommend doing a bunch of practice outside of this worksheet as well. Otherwise this worksheet would be about 500 questions long. You can find basically infinite questions online because it's trig equations, so sine, cos, tan, anything, squares and all that kind of fun stuff. As always, the link in the description for the worksheet. Again, it says Patreon, but it is completely free. It's just that I use that to host it because it's very convenient for me. There's also the A-level maths playlist, which has all of the live lessons I did last year, and there's also going to be kind of everything else that you need for the Discord and all of that fun stuff. So I'd recommend doing this worksheet again after you've watched it, a day or two after watching the video, but also once I've gone through one question, have a go at the next question yourself. That way we're doing kind of active learning. It's like it's an actual lesson and you'll actually get a lot of benefit from it. So without further ado, let's just get started. So solving trig equations, you're probably going to think, it's not that bad, it's quite easy, you've done it before. Well, let's actually have a think. If I said to you, could you answer this question? Sine x is equal to, let me give a good example of a half. Okay. What you'd probably do, and rightly so, is whip out your calculator and just do inverse sine of a half. So 30 degrees. Cool. And that is good enough for GCSE. But if we draw out the sine graph, you're probably going to notice something. So if I draw, we've got my y-axis here, and we're going to have a pretty long x-axis here. The sine graph looks like this. And it goes on in both directions forever. So if I'm looking forward, so if you remember, it varies between 1 and -1. So let's say a half is over here. This value here is 30 degrees. However, it also hits a half over here, and then over here, and also over here. So there's actually 1, 2, 3, 4 answers. But actually, because the graph goes on forever, there's actually an infinite answer, a number of answers for this. Infinite, it goes on forever. So when I ask, okay, sine x is a half, what is x? I don't give you enough information to solve the question. Because you could rightly say it's 30, and also this value, and this value, and this value, and you could write values going on forever. So we need to work out, first, how do we work out these other values? My calculator only gives me one value, and if I press equals again, it just keeps giving me 30. Interesting, right? So how do I work out the other values is step 1. But step 2 is they also have to give me a range. Okay, and that is the key point here. Now, using the graph, you can probably work out what the other values are. So for example, I know that this is 0 over here, and I know that this is 180. So that means this should be 30 degrees less than 180, so it should be 150. Should be. However, if that doesn't make sense to you, I've got some good news. There is a diagram that does all of the work for us. Now, I'm going to use this as an example question. This is the exact layout for a question that might be about 4 marks in an exam. The difference is that it's not usually as simple as this. They will have some numbers in the front and some other stuff. But as a base, it will say solve, insert trigonometry, for all values of x between two sets of values. In this case, 0 and 360. So in this case, we're limiting ourselves to only values over here, which is quite useful. Okay? Because we need to have a limit, otherwise the answer is just an infinite number of solutions. So how would you do it? Well, the first thing you do is exactly like you would expect. You would simply do x is equal to the inverse sine of 1. Simple as. So once again, 90 degrees. Cool. Fine, right? So those steps are the same. So we're at the same point. So if I use this as the first example here, as kind of just continuing this, let's work out how we get to the other values. We do something called the cast diagram. What does the cast diagram look like? Well, the first thing you're going to do is you're going to draw out your axes. Okay? And then you're going to write C, A, S, T in a counterclockwise notation, okay? I'm going to put this out there. This won't make sense straight away. This will take time because it seems somewhat arbitrary, okay? I'm just going to point that out. It is a bit arbitrary. So what does this mean? What do these things stand for? Well, it stands for cosine. You don't need to write these red bits. All sine and tangent, or tan. Now, what this actually means, so we know what it stands for, what does it mean? If you look, our value here is positive. Okay, we have a positive value. So we can draw a line in these regions for different kind of trig values. So this is sine, isn't it? So I'm going to draw a line for sine in the sine region. Okay. And I'm also going to draw sine in the all region, because sine is positive in the sine region and the all region. Why do I care about it being positive? Because it's a half, it's a positive value. Okay? Might not make much sense. I fully understand that, but I hope you can at least remember the rules, and with practice it will make sense, I promise, okay? So, once again, these signs, these symbols here, these regions represent where the trig value is positive. So where this right hand side is positive. So all means sine, cos and tan are all positive in this region. Sine means sine is only positive in this region. This region, only tan is positive. This region, only cos is positive. Because we have sine and a positive, we've drawn a line in the sine region and in the all region, because that's where it's positive. Now, this x value represents this angle here. And it also represents this angle here. So what's our alternative value for x? Well, the other thing to remember about the cast diagram is you read angles counterclockwise. Just like we wrote counterclockwise, it's also drawing the angles counterclockwise. So our other value, I told you this was 150. Well, let's do another color. Let's do it in green. What would the value of that angle be? Well, angles on a straight line add up to 180. So it's 180 minus 30, which is 150 degrees. So our two answers in this case are 30 degrees and 150 degrees. That is 4 marks. Again, this is assuming that the question was that it's between 0 and 360. Okay? If you change these limits, you change what values you can get. That we'll come on to later. Take a second to digest that, but we're going to do a ton of examples. This video is already quite long, as you can see, because this is a very difficult concept, okay? But with practice, this becomes very, very easy, and the cast diagram is the best way. And the reason is kind of hard for me to explain now without giving spoilers, but just to keep it simple, you don't need to remember anything with the cast diagram, except that it goes counterclockwise. If you try and use the rules seem really appealing. All you do is you subtract this or add this. But when it becomes negative, or the regions change, like the boundaries, it goes out the window and you need to do different rules. You'll end up needing to remember about 20 or 30 rules. That's not a smart thing to do. Cast diagram, you don't need to remember anything, you just need to learn how to use it, which comes with practice, which is why I prefer it. So, let's go back to our other example. let's quickly discuss all the different ways that I'm going to help you in your GCSE or A-level maths careers. First of all, I wanted to talk to you about the YouTube members. This is a really cost-effective way of getting tutoring. So I'm going to do weekly live streams for GCSE and A-level maths, and that all comes for £18 a month, and you get at minimum an hour of tutoring per week in these live streams. At the moment, they're quite small, so you basically get tuition for about £4.50 an hour, which is really, really cheap. The second thing is the Patreon. For those of you doing A-level maths, I have already completed AS Stats on my Patreon. It is a full course with worksheets, mark schemes, videos. I answer all the questions. We're going to do exam papers and everything that needs doing. We're halfway through mechanics as of yet. And lastly, there's tuition. I still have places in my group classes for A-level maths and GCSE maths. For GCSE, it's £30 an hour, and for A-level, it's £40 per hour. So if you want to let me know if you're interested, just email me or join the Discord, where I'm very, very active all the time. Anyways, back to the video. So going back here, our first value for x, if I just write it underneath just to keep everything nice and neat, is 90 degrees. Now we've got sine again, which, fair enough. So what's our next step? Well, we need to draw our cast diagram. So let's draw our cast diagram. Again, it's just a big quadrant. And remember, you're writing C-A-S-T. Don't bother attempting this by yourself yet. I've got another example where you can attempt it by yourself. Okay? This one we'll do together again. Again, our answer here, 1, is positive. So we're going to draw a line where sine is positive. And this is where things are going to get a bit interesting, because it says 90 degrees, right? So technically speaking, I'm going to draw in another colour just to make it clear. It's going to be here, because that's 90 degrees. Can you see that's still technically in the all quadrant? And it's also going to be here. 90 degrees. Okay? Or in this case, it would technically be 0 degrees, but it's 90 degrees from the last line, okay? So, what are the other values that we have? Well, we need to work out what this angle is here. Well, it's 180 minus nothing, right? Because it's along the line, which is just 180 degrees. Again, 4 marks. These questions were 3 or 4 marks every single time. They're pretty quick once you know how to use the cast diagram. What I want you to do is have a go at the next example, so this one down here, and then I'm going to go through it as well. But if you notice, the regions are different, okay? Because I want to expose you to another type of question. So I expect you only to get one of the 2 answers, which is totally fine. Okay, with this example, I have thrown at you a few new things. First of all, we're using cos instead of sine. That should not really change anything, okay? But if you look at the region, instead of it being 0 to 360, it's minus 180 to plus 180. Don't fret, okay? It's going to be the same thing. However, we'll also need to work out a negative answer. This will make sense, because before, negative angles doesn't really make sense, does it? Because angles are a one-dimensional measurement, or at least you thought. They would only really be, they're scalar, not vector. Well, in this case, we do have negative values, okay? So once again, what we're going to do is do x equal to the inverse cos, in this case, of a half. So x is equal to, and then let's just change it around. So we have inverse sine cos a half, so do a fraction. 60 degrees. That's a nice number to have. Again, I have picked these so the numbers are quite nice at the moment, but technically they can be long decimals. But that, again, that shouldn't change anything. C-A-S-T. Now, our answer is positive. So I'm looking for where cos is positive. Once again, that is in the all section. You're almost always going to have a line in the all section. It's also in the cos section. So now we have 60 degrees and 60 degrees. Cool. If you notice, if I draw a little dotted line going around to work out this value, what would that be? Well, this is a reflex angle, isn't it? So these angles add up to 360. So it's 360 minus 60. So in other words, it's 300 degrees. But look at this. It says minus 180 to 180, so it's too big. Now, I actually like to write out all of the answers and then cancel them out afterwards. So what I might do is do this and then just draw a little line through it. I'm not scribbling it out. I'm showing the examiner that I've worked out the other value and then I'm getting rid of it. And that's a very smart thing to do. So you have the value and then you're saying it's not part of the region. So now, how do you think I can get negative values? Well, what I'm going to do is I'm going to erase, hopefully not the whole damn thing, this part here. So I've erased that. It's typical, isn't it? There we are. So, how do you think I get negative angles? Well, if you notice, I told you we read angles counterclockwise. They always give you positive values. So positive angles. So to get negative angles, you read clockwise. And this always works, by the way. So our first negative angle, well, if I read it clockwise, it's just 60 degrees. Or negative 60 degrees. The other negative angle is this. And that's just, again, since it's a circle, I should probably continue that here. Since it's a circle, it adds up to 360. 360 minus 60 is 300, so it's minus 300. But if you notice, that's also out of the range. So draw a line through. So my actual final answers, two values, are 60 and negative 60. As a hint, if it just has x inside the trig value, so what I mean by that is there's no 2x or 3x or half an x. If it's just x inside sine, cos or tan, and the range is 360 degrees, so minus 180 to 180 is 360, 0 to 360 is obviously 360, you're usually only going to get two answers. Just keep that in mind. Every 360 degrees, you only have two answers, but this is assuming there's nothing in front of this x. So again, there's no 3x, there's no 2x, there's no 5x, there's no half an x. Okay, so keep that in mind. You should have two answers for every range of 360 degrees. Minus 180 to 180 is still 360. So I hope that makes sense. Let's go back through from the beginning, okay? If you want, you can skip this section if you're comfortable, but I'm willing to bet most people aren't. Practice, 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 okay? And we're going to do a lot more practice. So starting from the beginning, just lightning fast recap. First of all, we can't solve trig equations unless we have a range, because they go on forever in both directions. So instead we use the cast diagram. To do a cast diagram, you draw a little quadrant, so literally just split your page or section in four, and you write CAST going counterclockwise. Okay? What these represent are cosine, all, sine, and tan. And what they mean is that in those quadrants, those trig identities, those trig values are positive. So because we've only dealt with positive answers, so on the right hand side it's positive, all we're doing is drawing lines where those trig values are positive. So sine is positive in the S quadrant and the A quadrant, so we draw lines there. If it was cos, we'd draw in the C and A. If it was tan, we'd draw in T and A. If it was negative, we would draw it in the opposite directions, but we're going to come on to that a bit later. With this first example that we had here, all you need to do is draw your lines and then read the values off counterclockwise. That should be nice and easy, hopefully. With this second example, we actually needed to get negative values, and this is what you need to remember. You read positive angles counterclockwise. So if you're going to the left with your angles, you're reading them as positive angles. If you read them to the right or clockwise, you're reading negative angles. That's all you need to remember. So if you want negative angles, you read clockwise. If you want positive angles, you read counterclockwise. That's all you need to remember. Again, this is really simplifying it. This cast diagram is so powerful because it simplifies it. You don't need to remember rules, you just need to remember a few key things. So which regions are positive, and then which way you need to read for positive. That's it. That's two things as opposed to the list of rules that you might find online. So I hope I haven't terrified you too much just yet. If you did have a go at this question, really well done. That's a good effort. There are two new things in this question, right? First of all, we don't just have x. Instead, we have something plus, well, theta in this case, plus 30. So we have to do some special stuff. And likewise here, equals minus 2.5. It's a negative. But keep calm. Remember the two rules you need to remember. Which way you read for positive and which sections are positive. That is it. So, what we're going to do, and we should note, by the way, that this is theta is between these values, not theta plus 30. And there are a few different things that people do in order to kind of work these out. Here's the first rule, and I would low-key kind of recommend you do this. If you think about it, at the end, what we're going to do is subtract 30 from all of our values that we work out, right? So let's say I was working this out for the first time. So I would say theta plus 30 equals the tan inverse of negative 2.5, right? That's fine. And I'd work it out just as per usual. So shift tan, good lord, negative 2.5. That gives me minus 68 point blah blah blah. And it says to one decimal place, so we're going to leave our answers to one decimal place. And then what you would do is you'd take away 30 from both sides, wouldn't you? You'd just do 30 minus, you'd do minus 68.2 minus 30. Right, and that'd be minus 98.2. And that would be kind of your answer in this case. Because we're doing that, we should really change what these boundaries are. Because what I don't want to do is accidentally miss a value. This is not a compulsory step. Okay? Mathematically, doing this is fine. But imagine for a second one of my answers was 200 for theta plus 30. I might cross that out. But if you notice, if I subtract 30, I get 170, which is actually a correct answer. But I've crossed it out because 200 is bigger than that. This happens to a lot of students. And remember, believe me when I say that this gets more complicated. They could put a 2 in front of the theta. So in your head, it might be a bit tricky to keep track of everything. What if it's 3 theta plus 45? Are you going to do that in your head to make sure values work? Or are you going to do what I would say is a smart thing and make your life a bit easier? This is super easy. All you do to change these limits is do exactly what it says. So in this case, it says plus 30. So I'm going to plus 30 to all parts of the inequality. So minus 150, because, you know, minus 180 plus 30, less than equal to theta plus 30, less than 180 plus 30, 210. All I've done is applied the exact same thing. And if it was 2 theta, I would also double them. So I'll double them, then add 30. So minus 180 double that is minus 360, plus 30 will be minus 330. And that way, I'm actually looking at these for the beginning part, which is very, very useful. So that is what I'd recommend you do, is you should change the limits, just so you have to think as little as possible. Remember, in an exam, you're under pressure, you're panicked, your adrenaline is pumping through your body, so you're gonna make small mistakes. So if you limit those by reducing the amount of thinking you have to do, as weird as that sounds, you will make fewer mistakes. Okay? So there are a few things in here which are a bit spooky. A little bit spooky. First of all, it's a negative answer. Second of all, it's a negative angle. So let's draw our class diagram out before we go any further, because that is what we should always do. Because it's a negative answer, you would be right in saying we need to put it in the areas where tan is not positive. So we're not putting it in tan and we're not putting it in A. We're putting it in these two. But remember, it's a negative angle. So instead of it being this way round, it's actually going this way because it's a negative angle. Okay? Just to be super transparent. And now what we're going to do is we're going to go both ways round and figure out what on earth is happening. Now this angle still is 68.2. That's no harm, no foul. Now we want all values between minus 150 and 210. So if I keep going negative for a second, so if I try and work out what, and again I'm going to do these in different colors just to make it a bit more transparent. If I try and do that, what I'm going to have is 180 plus 68.2. So 180 plus 68.2. But remember, I've read this clockwise. So this is a negative value. That would be negative 248.2. But if I look at my limits, minus 150 is the smallest I'll go to. So I'm going to cross that out. That one doesn't count. Okay. Now what about if I read counterclockwise? That means I'm getting positive angles. So let's go. What would that be? Well, that would be 180 minus 68.2, which is 111.8. Is that inside my limit? It more than certainly is. Cool. We can keep going. We can now go and read this reflex angle here. What would that be? Well, that is angles in a point add up to 360. That would be 360 minus 68.2, which is 291.8, which is too big. Doesn't work. So once again, if you remember what I said, every 360 degrees, can you see the range here is 360 degrees? You're going to get two answers. So far that's proven true. Only if there is no number in front of the angle thing, the theta. Then more interesting things happen. If there's a 2 in front, we have twice as many answers. There's a 3 in front, we have 3 times as many answers. There's a 4 in front, we have 4 times as many answers. Likewise, if there's a half, we have half as many answers. Okay. What I'm going to do from now on is I'm going to draw green for reading counterclockwise, so the positive values. Okay? So counterclockwise. I'm going to leave this on the mark scheme just so it makes it a bit more easy. Will be negative because red is negative, green positive, right? That makes sense to me. Like that. Blue is going to be the value we get from the calculator because it's just a value we get from the calculator. Perfect. Are we done? No, we are not. Because that's theta plus 30. We're looking for theta. So now we need to subtract 30 from all of these values. Again, these two we don't need to bother because we know they're going to be outside the range because we adjusted our range. Smart. So minus 30 from this. You can use a calculator if you like. I'm not going to judge you. And the green one, if we subtract 30... Oh, I lost my calculator for a second there. 111.8 minus 30 degrees is 81.8 degrees. Those are our two values. That is a 4-mark question. Not bad, not bad. I'm hoping not bad anyway. We're going to see the next one is our first 5-marker. It only has one additional thing. There's going to be a number in front of the theta. But that's it. No more scary than that. So according to my recording software, it's been about half an hour already and we've done like 4 questions, so this is fun. We can start speeding up slowly though. So with this, I'm hoping you're thinking, yeah, not that bad, not that bad. There's a 2 in front of the x, but who cares? It's just a 2, right? 2's a weasel stuff. 5-mark question, just because there's a number in front of the x. Okay, easy. But remember, for every 360 degrees, we have 2 values. We only have 180 degrees here, so that's 1 value. But because of the 2, we're actually going to have 2 values again. But anyways, let's forget that. So, first things first, I would change the range. So we're going to times all of these values by 2, and then add 15. So 0 times 2 is 0, add 15 is 15. It's good to remember BIDMAS. You have to times first. If I add 15 then double, I get different boundaries, okay? Then that's going to be less than equals to. By the way, one other thing which is absolutely devilish It's so bad that they do this, right? Sometimes they don't put the equal sign. Sometimes they do. We have to be so careful. In our example so far, because I'm not a bad person, I've made them so that the values are between this anyway. But there have been questions where it's gone from 0 to, let's say, 360, and it includes 0 and 360, but people cross out the 0 and 360. Likewise, there have been times where 0 to 360, not inclusive, there's no equals, and you drop marks, and it's so harsh. Please, for the love of God, remember this, okay? Keep looking back, keep double checking. And for the upper value, doubling 180 gives me 360, adding 15 would give me 375. Perfect, now we can actually get started and let's have some fun. I mean, I say fun. All we're going to do is inverse cos 0.3. So inverse cos 0.3. And again, I'm going to write this in blue because it's just a number. 72.5, it says 1 decimal place. Let's leave it at 72.5. Now let's draw our little cast diagram. You know what, let's draw it a bit straighter than that. These shaky, disease-ridden hands that I have, man, honestly. So we have cast. Now, the answer is positive and the angle is positive. So because the answer is positive, we're going to draw lines where the cosine is positive, which is in C and A. Remember, A stands for all. So C and A, get a line. And because it's a positive angle, I'm going to draw it counterclockwise. So again, remember those rules. First of all, if the answer is positive, you draw lines in the positive quadrants. You don't need to think about the angle, just draw the lines. The second thing you think about is if your angle is positive or negative. If the angle is positive, you draw it counterclockwise. If it was negative 72, then I would have drawn this instead. Okay? So, now we need to think of our angles. So, first things first, what I'm going to do is find the other positive angle. So that means I'm going to go counterclockwise. So that is going to be, because this angle here is also 72.5, remember when you draw the lines the angle is always the same, then that angle is going to be 360 minus answer, which was just by 72.5, which is 287.5. Let's draw that in green. Okay. Now, what I'm going to do is find my negative answers. So I'm going to get rid of this line here. Boop. My negative answers are going to be negative 72.5. But before I continue, if I have a look at the range, it's 15 to 375. So in other words, I'm not considering any negative values, right? So if you're comfortable, you can just ignore this part if you're comfortable. Because you can see I'm not going to need any negative answers, so why bother even writing them? Because all I'm going to do when I write them is immediately cross them out because we're not even considering any negatives. So if you want, you're more than welcome to just ignore this part. But for those of you that want to, you need a little bit more, that's fine. And then this next value would be 360 minus 72.5 again, which you've already done is 287.5. And I am aware that I did the negative afterwards, which again is not in our range. Cool. So we're practically done. Can I just... Okay, I did write that in green. Cool. So, if I'm now working out x, what would I do? Well, I would subtract 15 from both sides, then I'll divide by 2. So let's do that. 72.5. Again, think of it in terms of algebra. You wouldn't divide by 2 then minus 15. You would subtract 15 then divide by 2. Those will give you two different answers. So subtract 15 and then divide the answer by 2. And that gives me 28.75, but it says 1 decimal place, so 29 degrees. Sorry, not 29. What am I talking about? 28.8 degrees. And for the next one, we're doing the exact same thing. So 287.5 minus those 15 degrees and then divide by 2. 136.25, so 136.3. Those are your two answers. 5 marks, man. Like, I get that this isn't the easiest topic, but I'm hoping that even if you're a bit confused, you can see that once you get the hang of this, it's so many marks for something that isn't really that bad. And I want to point out one more time, there are 2 other methods which I would like you to explore if you're really uncomfortable with the class diagram. If you want to, you're more than welcome to. Every year I've had students that either use the rules, if you look up trig equation rules, you'll find it online, and the graphs, and they do well. They get the answer. But I will say that they hate the topic far more than people that use the class diagram, because with the class diagram, there's less to remember. Sure, learning how to use it takes a bit longer, but once you know how to use it, I'm going to be real with you, sometimes there was a point in my life where I had gone a year and a half without tutoring any A-level maths, and then I had to tutor A-level maths, and the first topic was solving trig equations, and with the class diagram I was able to do it still. You know, it's not that bad. It's a very useful tool. Okay, so for this question there is another slightly new thing. However, you're actually going to figure out that it's not anything bad. So we have this solve between 0 and 360, 5 cos x minus 40 equals 2. Now you might think, what does the 5 do in front of the cos? Well, that's a really good question. What if we just divide both sides by 5? So the reason why we have to change things for stuff like this is because we can't get rid of, like for example, the minus 40. We can't get rid of it before we do the inverse cos. But if you can get rid of it before you do the inverse cos, for example, this 5, then get rid of it. Divide both sides by 5 first. That'll be my number 1 piece of advice. And then it just looks like, honestly, a bit easier than the last question we did. So 2 over 5, which is of course 0.4. Now what I'll do is I'll quickly apply whatever this thing is inside the bracket to my inequality. So I'm going to subtract 40 from all of it. So that's minus 40 less than equals to x minus 40, 320. Okay? Cool. Now we do inverse cos, blah, 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 all that fun stuff. Easy peasy, lemon squeezy. So let's do the inverse cos real quick. Inverse cos of 0.4 gives me 66.42. It says 2 decimal places, so we're going to keep it to 2 decimal places. I know, shocking. Equals 66.42 degrees. Like so. Now let's draw out our cast diagram, C-A-S-T. Again, our actual answer bit here, the thing on the right hand side, is positive, so we're going to draw a line in both positive quadrants for cos, which is of course A and C. My angle is positive, so we're going to draw it counterclockwise, so 66.42. To work out the other angle, well, we can work out the negative ones if we want. We do technically have a little bit of a negative here, but if you notice, so negative means we go clockwise. That's going to be 66.42, because remember, the angle between the line and the horizontal axes is always going to be the same for these two. So we can see that that's negative 66.42, because again it's clockwise. The other negative value is going to be all the way around like that, and that's going to be 360 minus 66.42. So we do 360 minus 66.42, which is negative 293.58. Negative 293.58 degrees. Both of those so far are not suitable. So let's find the other positive values. So if we get rid of the negatives, actually just this big negative one, if we're going around this way, we're once again going to have 360 minus 66.42, and that's going to give us positive 293.58, which is indeed inside this range. So if you look at this, these two are not inside the range, but this first one here and the last one are. So now all we need to do is add 40 to all of these values. So that would be 106.42. And also this one would be 333.58 degrees. It should also be noted, by the way, and this is actually something that's a bit smaller, is sometimes, in very rare situations, but it does happen, they might say to 3 significant figures. And if you notice, when I added 40, I gained a significant figure, in which case I would have to trim off one of the answers. So let's say if it's 4 sig fig here. When I add 40, 4 sig fig is actually only these first 4 digits. That's another thing they can do to really screw you over annoyingly. However, in most cases they do decimal places because they're not poo heads. Another new style of question. So we have a tan squared equals 3, and aha, I hear you say, probably not, you just square root both sides, right? You are right. Yeah, we don't need to deal with this. This is not part of our jurisdiction. Don't worry about it. Because we can get rid of it before we do the tan thing, we can just square root it. But you can probably tell by the sound of my voice, things are not as it seems. Remember, when you square root, you get a positive and a negative. So this is where we're going to have to split our page in twain. So split it in half, approximately down the middle. We have tan x equals positive root 3, and we have tan x equals negative root 3. Now this doesn't change the limits or anything, so we're still looking for only positive values. So you might rightly think there's probably going to be no values on this side. Maybe, but we're going to check anyway because that's what we do. So we're going to do both of these, nice and easy. So get our tan x out. So we're going to do shift tan. We're going to start with the positive ones just because it kind of makes sense to me. Of course. Root 3. I pressed F3 instead of the number 3. 60 degrees. Okay, fairly easy. So 60 degrees. Let's draw our little cast diagram. Draw it down here. C, A, S, and T. Now, we have a positive answer, so let's draw our lines where tan is positive, which is in A and T. And we have 60 degrees, which is positive, so we're going to start from here. Now, here's where I'm going to start showing you some shortcuts. Because we're not looking for any negative values, I'm not going to bother reading the clockwise version. Hopefully that makes sense, right? It saves you a bit of time, but I want you to kind of get comfortable with these small shortcuts that you can take. And then our other positive answer, again, as we know, this is still going to be 60 degrees, right? Because it's always the same. So that's 180, it's a flat line, plus 60 degrees, which is going to be 240 degrees. And that's it, right? There's no other values within 360. Cool. Now let's do the same thing, but with negative root 3. So change that to a minus sign. Negative 60. Probably could have worked that out ourselves, but it's always nice to double check. So let's go through it. If you remember, whenever you have a quadratic, so a squared, it generally speaking increases the number of answers that you have. Generally, it actually doubles them. So let's see if that holds true for trig equations. So first of all, you notice that we've got a negative answer, which means we need to put a line where tan is negative, which is in the sine quadrant and the cosine quadrant. Now, it's a negative value, so we're drawing this clockwise. Now, do I care about negative values? The answer to that is no. So I'm not going to bother doing the other clockwise value. I'm not going to bother, right? Because there's no point. So I'm not going to do any clockwise values because we don't care about negative angles. So what am I going to do instead? What I'm going to do is I'm going to go counterclockwise. Remember, you can always read clockwise and counterclockwise. Always. If I wanted to, I could read negative values from this one on the left. I could read negative values from the one on the right. Likewise, I can read positive values from the one on the left and positive values from the one on the right. There's no limit. Okay, so you can always do both. So This would be 180 minus 60, so that would be 120 degrees. Which does fit inside this boundary, right? So that works. And likewise, if I continue this line going off, that would be 360 minus 60, which is 300 degrees. Which also works. So in other words, it does actually have more values. It has 1, 2, 3, 4. It has double the number of values. So at the end, I'd literally just write in a box x is equal to 60, 120. I like to put them in order of size. I don't know why. I'm just like built that way, you know. Those are our 4 answers for our 5 marks. Again, for a 5 marker, it's not that bad. There are far worse questions that are worth fewer marks in A-level maths. Believe you me. But hopefully that makes a bit of sense, and hopefully you can see what kind of happens. Again, the aim of these videos is to expose you to all different types of questions. Again, I want to preface this one more time. I've left this kind of late into the video, but this isn't covering every exam question that exists. We're doing that a bit later. We're going to go through whole exam papers. So you will find other questions, but you should be able to use what you know from this video to answer them. But if you're ever unsure, you can always email me. My email's in the description. You can also leave comments. And here is the final type of question, and as you can see, it's a big fat 9 marker. So you might be slightly intimidated, but do not worry. In AS, not too bad. There are 2 equations in AS that you need to be able to use to rearrange trig equations. So if you look here, it says show that this equation, cos squared x equals 4 minus sin x, can be written like this. And there are 2 equations you can use. So I'm just going to write out this initial question first. And then I'm going to show you the 2 equations. First of all, that you might be expected to use is the fact that tan x can be written like this. And the next one is this. In A2, so in year 13, you will be expected to use a few more. But those are the only ones you need for AS, okay? These are the only ones you need to use for year 12, for your year 12 mocks, and all the exams in year 12. Which is really handy, because it's actually quite simple. If I look at this, and I look at the answer, what is the difference? Well, the first things first, is tan here at all? No? Okay, so I'm not using this one. I have to use this one. That's how easy it is. If you have tan, you're using the tan one. If you don't have tan, you're not using the tan one. Easy, easy. Now, let's actually look at the difference. So we have sin x, that's the same. 4 and 2, okay, they're still numbers, so that's still the same in air quotes. But if you notice, there's cos squared here and no cos squared here. So all they're doing is they're rearranging cos squared in this equation and subbing it in. That's it, done. That's how easy it is. And that's why I've only put 1 question in here. Just as a recap, if there is a tan, then you use this first one. There's not, you using the second one. Then you see what disappears. Either cos squared becomes sin squared or sin squared becomes cos squared. That's it. That's the only thing they can give you in AS. So, all you need to be able to do is rearrange this, but come on, man. You just minus sin squared or you minus cos squared. That's it. So we want to rearrange for cos squared, so I'm just going to minus sin squared from both sides. So cos squared x is just 1 minus sin squared x. And that's how easy it is. Sub that in, rearrange, bish bash bosh, you're done. So 6, 1 minus sin squared x equals 4 minus sin x. Expand, we have 6 minus 6 sin squared x equals 4 minus sin x. And now you have to decide which, do you want to move everything to the right side or to the left side? Well, if I have a look at the answer, the sin squared x is positive. So I'm going to be moving everything to the right hand side. Okay? Because again, here it's negative, so I need to move it over to make it positive. Yeah, that's pretty much it. I was going to say some more stuff, but there's no real need to. So add 6 sin squared x to both sides. So we have 6 sin squared x. Then I'm going to put the minus sin x because that's what it tells me to do in this equation here. And then 4 minus 6 is minus 2 equals 0, which as you see from the answer is exactly what we've done. Easy as sin. It then says hence solve, and you guys know how I feel about the word hence. Hence literally just means use part A. So I'm not going to write this equation, I'm going to write this equation. minus sine x. And how do we solve that? Well, if I have a look, this isn't a quadratic equation, right? If I write the general form for a quadratic equation, instead of x, we just have sine x. That's it. So in other words, x is equal to sine x, okay? So all I'm going to do is solve this equation using the calculator, the quadratic formula on the calculator. Except it's not the quadratic formula. I keep calling it that, but it's not. So menu down twice, one to the right, equation slash func, polynomial, degree, since it's squared, it's going to be 2. Type it in as if it was this. So I'm going to get rid of this for now because we don't technically need it. So the number in front of x, or in front of the squared term, is 6. The number in front of the non-squared term, the linear term, is -1. And the constant term is -2. So equals twice. So we have sine x equals 2/3. And we also have sine x equals something else. -1/2. We're getting a load of marks already. This is 2 marks already. I haven't really done anything yet. Now what do we need to do? Well, it's the exact same as our previous question. We need to do 2 separate solvings. So what I'm going to do is I'm actually going to move this. I'm going to move it. Now that we've done with the hence bit, I'm going to move it under here because we've done the hence part. So what we're going to do is I'm going to spread this out a little bit just so we can have a nice bit of room. Straight line, right? And then all we're going to do is solve it as per usual. What is our bounds? It's 0 to 360. So let's write this down over here as well. 0 less than equal to x less than equal to 360. So let's go back to our original thing. So up twice to the left. We're going to do inverse sine of 2/3. Oh, that was close. 41.8. Does it say how many decimal places? 1 decimal place. 41.8. By the way, where it says where appropriate, what that means is if you've got a whole number, let's say 40, you don't need to add the 0.0. It's only where you need to actually round. That's a fat thing. Oh, let's turn back stroke. Okay. So let's do the good old-fashioned cast diagram. C-A-S-T. Again, I'd recommend, by the way, pausing the video now and attempting these 2 ones yourself. Just really quick. On a scrap piece of paper, just draw it out quickly. And since it's a positive answer, we're going to draw our lines where sine is positive. So that's in A and S. And I can see that my angle itself is positive. So that is here. And then because I don't care about negative angles, I'm only going to draw the positive angle here. So as we know, this is still 41.8, because of course it is. So we're going to do 180 minus 41.8. So 180 minus 41.8 gives me an answer of 138.2. And do the same thing for sine x. Again, I haven't bothered with the negatives because we don't care about negative angles. So here, let's do the same thing. Sine minus, I'm going to do 0.5 just because I can't bother to use the fraction button. You find I'm dreadfully lazy. Okay, again, cast diagram, good old fashioned. By the way, I know I get this question quite frequently, is can't I just use the same one? The answer is absolutely if you want to. The reason why I do 2 separate ones is because when I'm teaching you guys, if I start drawing an extra 2 lines and doing all that stuff, it can get a bit complicated and confusing. So for you, go ahead, but bear in mind you might mix yourself up. For me, I'm not going to do that. So -1/2 means we're going to do it where sine is not positive, which is in the CT areas, regions, quadrants, whatever you want to call them. And it's -30, so indeed we're going to go this way around. Now, I don't care about negative values, do I? So I'm not going to go clockwise anymore. I'm going to go anti-clockwise. In fact, I'm going to put a nice, neat line through there. So if I go anti-clockwise or counterclockwise, I have this value first, So that's going to be 180 plus 30, which is 210 degrees. And I'm also going to have 360 minus 30, which is 330 degrees. Both of which are inside this region. So once again, it's a quadratic, so I get 4 answers. Makes sense, right? So my final answer I put at the bottom, and I write it all together just to make it super clear to the examiner, to my teacher, to whoever is reading this, that I've got enough answers. Again, they only check your working out. Well, okay, not always, but they check your working out after they've checked your answers. If they can clearly see you got all 4 answers right, they just tick it. And that's a 6 marker they just tick for free. So that was a really long video. So well done for making it through the whole thing. I'd recommend finding other questions and also attempting these questions again by yourself in a day or two. Again, links in the description. Feel free to share this, like it, subscribe, etc. if you do enjoy this kind of content, just to keep me motivated in making it. But yeah, hope you have a wonderful day.